In this video, I'd like to show an example of chi-squared test of independence. Chi-squared test is used to determine if there is a significant relationship between two categorical variables. In other words, this test is used to determine if two categorical variables are independent or not. There are 3 steps and 4 steps in testing procedure. In the pre-step, make an expected frequency table by the formula shown. Expected frequencies are predicted values assuming independency. On the other hand, observed values are actual values obtained from experiments. Step 1. State a null and alternative hypothesis. Unlike other hypothesis testing, these statements do not change for each question. The null statement is always there is no relationship or independent. The alternative is always there is a significant relationship or dependent. Step 2. Find a critical value in a table using the given alpha value and the degrees of freedom. Then indicate the rejection region. This is a chi-square distribution table. The first column shows the degrees of freedom, and the top row shows the given significance level in a question. The intersections in the body of table are critical values. Please note that chi-squared test uses the right-tailed test. This means that the rejection region is always the right-tailed area. Step 3. Calculate the test statistic by the shown formula. Step 4. Write the decision and a conclusion statement. Let's try an example. Here, we use the chi-squared test to determine if the relationship between weight perception and smoking status in adolescents are independent or not. For the pre-step, calculate the expected frequencies using the formula. Please note that overall value or grand total is 598 in this case, so we use it on each denominator when calculating. For the first one, simply use the formula to get 6.8. It is rounded to 1 decimal place. Given that the actual observed frequency is 9, the expected value seems to be not so different. Repeat the process in the same way to get 53.4 for the center top cell. Likewise, the top right becomes 9.8, which is also not too far away from the observed value of 13. Continue in the same way to get the bottom frequency values as shown. You'll notice that all the expected frequency values are somewhat similar to the actual observed values. We'll use these results to calculate the test statistic later. Step 1. State the null and alternative hypothesis. The null means nothing happened, so it always holds the statement of no relationship or independent. We use H0 as the null and H1 as alternative statements, or you could use HA notation for the alternative hypothesis. To write the statements, we can make use of the wordings in the question. That statement goes into your H1 statement. Therefore, no relationship statement in the null statement. Step 2. Find the critical value and the rejection region. First, identify the given significance level alpha, which is 0.05. Then find the degrees of freedom using the formula. Go back to the table to determine the number of rows and columns. The number of rows is 2, and 3 is the column number. Substitute 2 into all, and 3 into C to get 2. Let's look up the chi-square table using alpha equal 0.05 with 2 degrees of freedom. First, locate the degrees of freedom 2. Then select 0.05 from the top row. The intersection of those to get the critical value is 5.991. We have now found the critical value. Remember that chi-squared test use right-tailed test. So the rejection region should be the right side of 5.991. Therefore, the statement of the rejection region is as shown. Then calculate the chi-square test statistic in the next step. Step 3. Here is a formula to find the chi-square test statistic. At first glance, it looks complicated. But it is simple if we create another table. We make use of the expected frequency table created in the pre-step. For the observed frequencies, we just copy the original data values in any order as long as they are matched properly with the expected values. For the expected frequencies, we copy the values calculated in the pre-step. For the third column of the table, after observed value minus the expected value, 9 minus 6.8, square the answer to get 4.84. Do not erase this number from your calculator. Then, for the last column, the third column value 4.84, which you still have on your calculator, divide by the second column value 6.8 to get 0.7118. Please note that I rounded the number to 4 decimal places. In the same way, square of 48 minus 53.4 to get 29.16. Keep this value 29.16 divided by 53.4 to get 0.5461. Repeat the same way to get all values. Please use the square key function from your calculator when you calculate the square part to avoid some miscalculations. As the final step, get the sum of both columns, that is the test statistic value, which is rounded to 2.608. I rounded to 3 decimal places as the critical value has the same 3 decimal places. Now we have 2 chi-squared values. One is the critical and the other one is test statistic. We need to compare those values to make a conclusion next. Step 4. Conclusion. In a conclusion, we need to write 2 sentences. One is a decision and the other one is the interpretation. For the decision sentence, decide whether we reject a null hypothesis or not. Please do not say accept a null when you cannot reject a null, as they are not equivalent. For the second sentence, we need to state whether there is enough evidence to support the alternative hypothesis or not. In case we rejected a null, then we say there is enough evidence to support the alternative. Of course, we need to write the specific scenario along with a question, and not just H1 statement itself. In case we could not reject the null, we say there is not enough evidence to support the alternative. Let's apply that for the specific question then. The diagram is showing the rejection region, the right side of 5.991 from second step. We just found the test statistic for this question as 2.608. Placing the test statistic on the number line, we find that it is not in the rejection region. Since the test statistic is less than the critical value, we do not reject the null hypothesis. We could not reject the HO, so now we cannot support the H1 statement either. Let's go back to the first step to find the H1 statement. Here is the first step slide. The bottom one is the alternative statement, so we just copy the sentence. We just copy the alternative statement here. Remember that we cannot support the alternative in this case. There is some tedious calculations in finding the test statistic part. However, I hope you are able to grasp the whole steps. Thank you for watching. See you next time.